Okay, so we know a point. We know f of 2 is equal to 3, and we know the derivative of f of 2 is equal to 5. We need to find an equation of the line tangent and a line normal to this graph. Now the problem is, we don't know the graph. But we don't need to know the graph. What does the derivative tell us?
The slope.
Okay, the slope of what?
The line tangent.
What? Okay, this not exactly.
A certain point on the slope.
Of a certain point. The derivative tells us the slope of a graph at a specific point. So it's not just the slope of a graph, it's at a specific point. So we're not looking for the slope of the graph. We're looking for the slope of a specific point. We know where that point is. The point is what?
Attention staff and students, we have 2 vehicles that need to be moved immediately from the south parking lot.
So that's the point. We know that point. We also know the slope at that point. Where's the slope at? I mean, what is the slope? 5. Right, that's given to us. So that means that our slope is here. So go down 5, 1, 2, 3, 4, 5, over 1. Is that right? Yeah. So, yeah, up 5 to the right 1 is the same thing as down 5 to the left 1. So this is the line tangent to it. So all we gotta do now is write the equation of the line. Okay, so let me explain how I got that again. So this point's given. The slope at this point is also given. We don't know what the graph looks like, but that doesn't matter because we know what the slope looks like. We know what the line tangent to that point looks like. This is the line tangent to it. So now all we gotta do is write the equation. So when you write an equation of a tangent line or a normal line, you can always start with y equals mx plus b. We know our slope is what? 5. We also know our x and y coordinate. What's that? Okay, so 3 is y. And all we're looking for now is b. So 3 is equal to 15 plus b, or 10 plus b. And then b is equal to negative 7. So your equation of line tangent is this right there. Any questions there? You can go ahead and write the equation of the normal line yourself. You should be able to do this. Hardest part is figuring out what the question was even asking and what it looks like.
Why did you have to graph it?
You didn't have to. I just graphed it so you guys can see it. So go ahead and write the normal line yourself. If you haven't noticed, you need to be able to write the line tangent to it and normal. Because that's why it's appearing everywhere in your homework. You always got to do it. So if you haven't figured out how to do it now, figure it out. (18, 19, and 20 are the same type of problems. So I'm only going to do one of them. Because I just said to do the normal one yourself.
Oh.
Yeah. Remember, normal line is perpendicular to the tangent line. Okay, 19 and 20, find tangent and normal curve. So you gotta take the derivative of those. 18, find the derivative and use it to find the equation of line tangent to the curve at x equals 3. Alright, so I'm only going to do one. So it looks like 20 has the most checks. So I do that one. Okay, any questions with 17?
What was the number one?
What?
What would the normal be?
What would the equation be? Y equals negative 1/5 x. And then what's the what do you guys get?
I got 3 and 2/5.
17 over 5.
17 over 5.
Is it cool if I just leave it as 3 and 2/5?
What?
Is it cool if I just leave it as 3 and 2/5?
When do we ever use mixed numbers after algebra 1? Never. Leave it as improper.
Wait,
It's called improper.
what's that
That's
f
what
of
it's
2 is equal to 5? What is that one you said?
What's it again?
The f of 2 is equal
Oh.
to 5?
Okay, so this is what you missed. So this means derivative. So this is the function. This is the derivative of the function. So this is what you missed. So to find the derivative is what I'm about to do now. So you want to make sure you pay attention to that. Alright, so for number 20, we got to find the derivative of y equals the square root of x. Okay, to find the derivative, you're going to use that formula for the derivative. The limit as h approaches 0 of a or x plus a minus f of x over h. So you plug it in that. Yeah. Alright, fine.
Right point.
Okay, yeah.
5.
You got that, Janice? Okay. Okay, so now you plug it in. So we got the square roots of x plus h minus the square root of x over h. And remember, you should be writing the limit each time, right? Because we haven't taken the limit yet. I'm just not going to write it each time. What do we do here? Yeah, you multiply by the conjugate. Okay, so you always multiply by the conjugate. You're dealing with square roots and there's nothing else you can do. That's usually going to be your next step. So let's put that in parentheses. Multiply by the conjugate. That's going to be x plus h plus the square root of x over h. Oh, no, it's not. Just kidding. X plus h plus square root of x. Okay. Questions so far? So it's kind of like that last chapter. You just plug it in. Okay, we're going to FOIL this right here. So we got x plus h. This time, when you multiply the outside and the inside, those will cancel out. And then we just have minus x over h times x plus h plus the square root of x. X's will cancel out, so we have h over h times x plus h. Square roots plus square root of x. H's cancel out. So you got 1 over x plus h plus square root of x. H is 0 when you take the limit. So it's going to be 1 over square root of x plus square root of x. And I think they tell you what x is. X is 4. Yeah, we did a problem just like this. Plug it in. 1 over, that means you guys aren't looking at your notes when you need help, obviously. So you get, that's 2 plus 2 is 4. We just did this yesterday. Yeah, this exact problem. Yeah. Okay, and then the question's asking to write a tangent and a normal curve. So that's our slope, 1/4. If x is 4, how do we find y? Yeah, you just plug it in, right? So you get 2. So for a tangent line, y equals mx plus b. We're going to plug in everything we know. 2 equals 1/4 times 4 plus b. 4 to cancel out, so 2 is equal to 1 plus b. b is equal to 1. So your tangent line is y equals 1/4 x plus 1. Yeah. Plug in 4 into x. And then that tells you the y. Alright, and then for your normal line, same thing, y equals mx plus b. So what's our slope for our normal line?
-4.
So -4, if 2 equals -4 times 4 plus b, so 2 is equal to -16 plus b, b is equal to 18. So your equation of the normal line is that. Alright. Any questions? Okay, last one. Number 26. Okay, so derivative tells you what?
Slope.
Tells you slope, right? So to graph the derivative of this function, we need to graph the slope of this. Okay, so this one they made easy for you, right? Because everything is kind of a straight line, so you can easily find the slope. So you're going to draw a graph underneath. Try to put the x intervals around the same place. It's going to make it a little easier for you to graph. Okay, so from -4 to 1, or from 0 actually, -4 to 0, what's the slope of this part here? Not 1. 1/2, right? You go up 1 over 2, up 1 over 2, or you go up 2 over 4, so the slope is 1/2. So from -4 to 0, your slope is 1/2. Right, so at -4 is 1/2, at -3 is 1/2, at -2 is 1/2, at -1 is 1/2, at 0 is 1/2. So your graph looks like that on that section. Because your slope is 1/2. From 0 to 1, what's your slope?
Down to so none.
What?
-2.
No.
From 0 to 1. Oh, -4.
-4 is your slope, right? Because you go down 4. 1, 2, 3, 4 over 1. So your slope is -4. Okay, there's -4. You go down to -4, and that's between 0 and 1. And then from 1 to 4, what's your slope? 0, so 1 to 4. Your graph is there. And then from 4 to 6, which is slope. Okay, you go up how many? You go up, let's say you go up 4, and you go over how many? 2, so that's going to be 2. So from 4 to 6, the graph is there. So that's the graph of the derivative. Yeah.
So the derivative doesn't have to be continuous?
That's what I was going to talk about next. Okay, any questions there? Now, for B, it asks you at what values of x between -4 and 6, so what values on this graph can you not take the derivative of? Well, where there discontinuity. When it's discontinuous, that's where you can't take the derivative of it. So, where is discontinuous here?
0 and 1. 0, 1.
Okay, 0, 1, and 4. 0, 1, and 4. So at those points, you actually can't take the derivative of it. Yeah.
How do you decide how long the line is again?
In between what intervals? So this is -4 and 0.
Oh,
So the slope is the same, all the way from -4 to 0. Alright, any questions there? So, if you're done with the homework, you can pass it forward. If you want to work on it a little bit more, hold on to it, turn it in whenever. But here's your assignment for tonight. Page 108, 36 to 41. It's going to be multiple choice. Same section. So, derivatives and the graph of it.